Hi everyone, welcome to Naresh Technologies. This is Srinivas. So in the last session, we discussed the introduction part of a binary search tree in a data structures and algorithms. So now in this session we'll see what are the operations we can perform on a binary search tree, right? So we can insert the elements into binary search tree, right? So we can delete the elements and we can traverse the elements. So first we'll see how to insert an element into binary search tree. Okay, here insertion of element into binary search tree. So first we need to create the node. So how to create the node? Structure representation already we discussed very clearly. Struct node is at most having three fields, right? So one is a data field to store the information, and next one, so left child, a pointer to left child, and next one pointer to right child. So this is a structure. So first initially we need to declare a global variable, just like in a single linked list and double linked list concept. Here also we need to declare one global variable, struct node star, that is a root element. So what is the initial value is a null, and of course a global variable default value, pointer type default value is always null, but if you want to show very clearly then you can write this null. So then first root variable will be created, and then we need to store the information. So first I'll explain the process of storing information into binary search tree. Okay, see for example, so first root is not pointing to anything, is nothing but root equals to null, is not pointing to any node. Suppose you have to create a node, so directly we are writing in the form of a circle, just consider, and I am storing some information, for example 50. And next are where we have to connect. First we need to check whether the node means what, whether the root is pointing to any node or not. So nothing but a tree contains any nodes or not, right? So this is the first node we created, right? So that directly root should pointing to this node is the first node, it's a root node. Next, suppose if you want to connect some other nodes, first I'll write some of the things. For example 60 I want to connect, is connected to right side. Next one 70 I want to connect, is connected to right side. 50 I want to connect, when compare with 55, compare with 50, 55 is a greater value, and come to here, when compare with a 60 it's a lesser value, so it will be connected here. Left side also some elements I am storing, for example 30, and next one 20, so like that we are storing some elements. Now I want to create a node. So first we need to create, for example node value, just consider 57 is a node value. So I am creating a node, 57 is a node. Node is ready, but where we have to connect? We need to start searching from the first node. If root is pointing to null means what you have created is a first node. But suppose if if a tree is already having some nodes, then you have to connect. Where we have to connect? We need to travel from root node to that particular parent node. Okay, first we need to compare with this one, current node, right, a parent node. Next we are moving like this. Okay, and this is, we should consider it as a parent node. So now we found the parent node. Next the node what you want to connect, newly created node, where we have to connect? Parent to left side or parent to right side, how to connect? So that is important. Here suppose if parent data is less than, or current data is greater than the parent data, then we are connecting to right side. If pair means what, if current node data is less than the parent data, then we have to connect it to left side, simple thing. Okay, so this is simply a connection, how to insert a node, right? So now we'll write the logic for this and you will get more clarity on this. Okay, see the code we are writing. Observe, suppose the function name we are writing void insert function. So what we want to insert, that we are collecting into D. Already root variable is there, so root variable is there, root is pointing to null. Root is not, means what, is pointing to null. Next, here in a insert we are creating one node. So what is that one temporary variable we are creating? Struct node star t is a temporary node. T we are creating. So t gets memory allocation somewhere. T gets memory allocation. Now we need to create the node first. So we know that how to create. So using malloc, and here it is, we need to pass the size of struct node. The size of struct node we are passing, and that we are collecting into T, and here it is a typecasting. I am not writing completely. Struct node star you have to write. We know, so many times we have discussed. So this is a memory allocation. Then node will be created. Here a node will be created with 3 fields at some location 1000. The 1000 will be collected into T. So temporarily it is pointing to this node. Next, data we need to store. Here it is a D value into T is pointing to this node, into T2 data we are storing the D value, and next left side child, right side child is a null. So T2 left equals to null, T2 right equals to null. So now node is ready. Suppose a value is just consider 50. Left side is a null, right side is a null. T is a temporarily is pointing to this node, right? So once you connected permanently, then the local variable, temporary variable will be deleted automatically. Next, where we have to connect, right? So first we need to consider the variable as a parent variable also. One more pointer is a parent. P is nothing but a parent. Okay, into the P we are taking root value first. Actually this is for remaining connections, but I am writing here. And next, observe, suppose here if root equals to null, so what it is representing means, right, the tree is not having any nodes at. What the node you have created, that is the first node. So by that time root should pointing to the newly created node only. So very simple, the 1000 you should store in a root. So here it is a T value we are storing into root. So connection is over, finished. Here T value 1000 will be stored here. This is the case. This is first node. Just we are creating the node, and next we are storing the information, and next one we are checking root equals to null or not. And if it is root equals to null means which is not pointing to any node in the tree. So what the node you have created is a first node. So that newly created node address we are assigning to root is clear. First node connection is very easy. Sir, what about a remaining nodes creation? Insertion, right? That we'll see. Else block. Okay. So followed by whatever the logic that I want to write clearly. Look at this. See, to understand easily, right? So first I will draw one tree. So with a few nodes. Okay. See. For example, so root is holding, just consider first node address. This is a first node is a 50. Next, this is one node, 60. This is one node 70. This is one node 65. Just consider. And here also we are writing some nodes like 30 and next 20, some nodes 25. Base addresses also I am writing 1000, so that it is pointing to this node. 2000, 3000, 4000, 5000, 6000, 7000. Addresses, random addresses, we know that. For this, left side connection is there, 2000 is pointing, right side connection is there, 3000 is pointing. For this, right side connection is there, 5000 is pointing, but left side no connection, null value. For this, left side connection is there, here it is a 6000 is connecting, no right side connection. Here it is no right, no left. And this one, left side connection is there, 4000 is connecting to this one, no right side connection. For this one, right side connection is there, 7000 and no left side connection, null, null, null. This is a tree with a few nodes. So we followed all the binary search tree rules. We know all the rules how to insert. Now I am inserting the new node. Okay. First I have created the node. We know how to create the node. For example, node value is a 67. Important. This is the node I have created. The node value is a 67 and address is a 8000. Consider initially null and null. Who is pointing? T is pointing. Temporary variable is holding the address 8000. Just now we have discussed how to create the node, how to store the data, how to make it left child and right child places null fields, and how to store the information into T. Node is ready. Next, how to travel from first location to last location. That is very, very important. Look at this. If block logic already we have written. Now we are writing else block logic very clearly. Already variable, parent variable we are maintaining. In the parent variable value, root value is there. So what is that root value? 1000. Next, inside the else block we are creating one more variable, struct node star. This is a current node we are declaring. In the current also we are storing that root value. So current also we are storing that root value. Root value is also 1000. Yes. Now how to travel from first location to last location to connect this node here? How? Simple, with the help of one while loop. While current CURR. See here, current value is 1000. 1000 is a true value. So while loop executes, control come inside. Now we should send the control to left side or right side. That you should understand. Node data is what? Is a 67. 67 we need to compare with a 50. We need to compare with a 50. 50 is nothing but a parent, or we can call it as a current also, no problem. Okay. Simply here it is a T2 node data. Here if T2 data is greater than current to data, is greater than current to data. So what is that current data? 1000 to data is a 50 and it is a greater than. So we should move to right side or left side? We should move to right side because it is a greater than. So simply T2 current to, so right will be stored into current. So current to write means 1000 to write is what? Is a 3000. 3000 will be stored into current. Else left value. So what is that left value? What is that left value means? Here it is. If it is a lesser value, then 2000 will be stored. Simply current to left value will be stored into current. This is. But every time whenever we are storing, that current value is assigned to parent, because we are finding that parent value is P. Is a parent you can write, or P we can write. So current value is 1000. Next, once again it will repeat. While current, what is the current value? 3000. Observe. While 3000 condition true, 3000 will be stored into parent. Parent is now 3000. Next, T2 data is greater than current to data. What is T2 data? Is a 67, is greater than current to data. Current to data is what? Current is a 3000. 3000 to data is what? 60. 67 is greater than 60 na? Again condition true. So current to write value will be stored into current. What is the current to write? 3000 to write is what? Is a 5000. So 5000 will be stored into current. One more step we are moving. Again while loop. While 5000 condition true, that current value will be stored into parent. Here current value, here it is. Simply, so current to data, current value will be stored into parent. Here parent value is a 5000. Next, again if T2 data is greater than current to data, now T2 data is a 67, but current to data is a 70 na? So condition false. 67 is greater than 70, condition false, it will fail, else block execute. Now current to left will be stored into current. Current to left is a 6000, this one. Now left side moving because less value na, that is simply 6000 will be stored here. 6000. And next one, here it is, again it will repeat, current value will be stored into parent, that is nothing but 6000 will be stored here, 6000. And next one, again T2 data is greater than current to data, here it is a 67 is greater than 65, yes condition true, then current to write value will be stored into current. Current to write value, 6000 to write value is what? Null value. That null value will be stored finally into current. Null value will be stored. Next time whenever we are repeating while current value is a null na, so condition failed, then while loop will be terminated. Finally we found the parent value where we have to connect the child. See, so parent is pointing to parent, either parent or P you can write. Okay, I think I declared P. Here it is, parent is pointing to the node where we have to create the new node, but directly you can't create na. Once again we need to check if T2 data is greater than parent to data, then connect the right side. If it is a lesser value, suppose 63, we connect it to left side. Once again, after while loop execution, if T2 data is greater than parent to data, please connect that T to parent to right. Here it is, so clearly I am writing. T value we are collecting to parent to right. So what is the T value is 8000 na? 67, T2 data 67 is greater than parent to data. Parent is what? 6000. 6000 to data is what? 65. 67 is greater than 65, yes condition true. So then we are connecting to right side. So 8000 T value we are connecting here. So this is connected. Sir, suppose if it is a lesser value, very simple, else block. Else block, here it is else block. right? Simply in a else block, so we are just writing t value we are storing into parent to left. We are storing into parent to left. This is simply, so whatever the t value is there, just consider instead of a 67 we are taking 63. 63 is less than the 65. So then by that time the node we should connect to left side, because it is a lesser value now. Now it is a greater value in this example. Okay, if it is a lesser value then connected to left side. As it is was a greater value, here we are connecting to right. So this is the insertion process. So if you want to insert, first we need to find out, so what is the parent node to insert the new node, and after finding the parent node, where we have to insert, to left side or to right side we need to connect. If it is a greater value than parent, we should connect it to right side. If it is a lesser value than parent, we should connect it to left side. Simple thing. Okay, so this is the insertion process in a binary search tree. Okay, in the next session we will see, right, how to delete, right, how to delete a node from the binary search tree. Okay, for more videos please subscribe to Naresh IT channel. Thank you all.